not do many introductions, and also we all know Jan-Piet Mens, of course. And Jan-Piet Mens is going to talk about a new DNSSEC-signing solution from NLnet Labs.
Yes.
Cascade.
And thank you already now for the new software.
You're welcome.
Very good. Thanks, Willem. First of all, still good morning. First of all, a small apology. I have to say this. Tuesday evening at roughly 21:30, I thought, well, everybody's at dinner or watching TV or something. I did a few Cascade demos that caused a little bit of a problem in .de. But of course, I mean, you know how it is working in production. Sorry, this is just a joke. I have nothing to do with .de. But I thought I have to address this because we're going to be talking about DNSSEC. And in that respect, one thing which applies to most of the CC-TLDs, and of course the generic TLDs, is the massive amount of quality that we have had over the years. .de, I think, had its last major fiasco in 2010. I think it was May, actually, 2010, when they published half a zone. It got truncated because file system full. I think it was 2010. Can't remember exactly. So really massive quality. Yeah, my joke was in bad taste. So, right. Welcome. I would like to speak a little bit about the Cascade DNS Signer. First of all, for those of you who do not know what this is, maybe, I mean, you're welcome to say, obviously, I'm glad you're here, but you might want to leave the room. This is, of course, a DNS zone. By the way, even if it looks very strange, and certain things look here very strange, this actually compiles, so it is really a valid zone. Question, you can raise fingers. How many of these records must be in a zone? How many of these record types must be in a zone? 1, 2, 3, 4, 17. The only correct answer is 2. A zone must have one SOA, one start of authority record, and a zone must have one NS record, okay? Anyway, you see here a number of relatively unknown or probably no longer really relevant things like a responsible person that has an email address that actually is an email address and then a domain name on it. Then you see here hinfo, which host information, which used to be very popular, which has basically a text field with 2 records. One is the hardware on which the domain is running, and the other is the operating system on which it's running, okay? Just as a matter of joke. And by the way, when you see me wobble, it's not only nervosity, it's a tremor in my hands. I can't do anything about it. Okay, so let's talk a little bit about DNSSEC, just a very, very small introduction. I assume most of you know what this is all about. In DNSSEC, we use, asymmetric cryptography is used, and signatures are added to resource record sets. A resource record set is a set of all records in a zone, in a domain, which has the same owner name, the same class, the same type, and the same, what else? The same TTL. Yeah, the TTL must be equal. And what DNSSEC does is it signs a resource record set with a private key, and this signature is added to the domain data. So in DNSSEC, we have new resource record types. I've got them all here, well, most of them anyway here. DNS key resource record contains the public key or the public keys. We'll mention that a little bit in a moment. Of the zones, we have the RRSIG, the resource record set signatures. We have a DS record, a so-called delegation signer record, which is the hash of the trust anchor of a zone, the main, let's say, key of a zone, which goes into the parent zone and is signed there. We have NSEC and NSEC3 records. By the way, NSEC3, that was actually the problem, apparently was the problem on Tuesday when, is it an earthquake or did I hit the screen? When .de had that failure, which was then mitigated by re-signing with an old ZSK. And we have CDNS and CDS records, optional, which Cascade also supports, which permit a parent zone to query a child zone to see whether anything's changed there. Any of you recognize this road sign here on the right? Yep. Who likes it? I mean, you recognize it, right? It's fake. And if you had a DNS validator, you would have been informed that it's faked. I switched the location of Utrecht and Arnhem, and this is the actual correct sign, and here it has been stamped with, with a seal verifying or validating that the road sign is actually valid, okay? So each zone in the DNS, in a DNSSEC environment, is signed with at least one key pair. A key pair consists of a private key, which I keep obviously private, and a public key. The public key is published in a DNS key resource record in the zone. And now begins a relatively complicated story, but I don't want to dwell on that terribly long. Zones are very frequently signed with two key pairs, a so-called zone signing key, ZSK, for the American ZSK, only for the Americans, because even the Canadians say ZSK. The zone signing key signs all the resource record sets in a zone, and the key signing key signs the DNS key resource record set, of 1 or 2 or whatever, how many keys we have. And alternatively, a zone can be signed with what is called a combined signing key. This CSK, there's nothing really combined about it. It's just a nice word to say we can only afford one key pair, okay? And very many zones nowadays are actually signed with a CSK. Power DNS, for instance, and the bind name server, those are two products which today recommend or start off as a default with a CSK. Cascade, as we'll see later on, prefers, by default, we can change that, but prefers the KSK-ZSK split. So resolvers are going to validate responses based on a chain of trust, which comes all the way from the root, respectively from a compiled-in trust anchor into our software. And all this is created, all this DNSSEC information is created with a so-called signer. And of these signers, there are a number of different ones. And the one that I would like to introduce today to you is the Cascade DNS signer. The Cascade signer was created by NLnet Labs, the wonderful people who, they really are wonderful, not only because some of them are here, but they really are fantastic. These are the people who created NSD or Unbound or the LDNS toolset, for instance. Really absolute fabulous software, which many of us use very frequently and all the time. Cascade is written in Rust. I have no preference for Rust, but it's written in Rust. And it comes with very sensible defaults and has quite good documentation. One of the reasons is I've patched it. But anyway, I'm a documenter. The Cascade began its alpha release in October 2025, and our friend Stefan Bartsmeyer, who is one of the chief architects of AFNIC, so .fr, and we had sort of like a thing going, who would be able to submit most tickets, most issues to the NLnet Labs Cascade repository, and he at the time tooted this, and I thought it was absolutely great, so that's why I'm using this. The Cascade release is slated for, I think, 15:30 today. No, I'm just joking, but sometime relatively soon, I believe June, somewhere in the first half year, it's released. Do you have any better information? Okay, good. Right, Cascade will, that is the plan, replace OpenDNSSEC. Yay! And so OpenDNSSEC is going away. OpenDNSSEC is a signer solution which lately has been maintained by NLnet Labs. And Cascade comes and replaces the XML configuration that OpenDNSSEC had with TOML files. I'll show you an example in a moment. We have no database. We do not require a database management system for Cascade, contrary to OpenDNSSEC. We don't require root rights, so Cascade can run as a perfectly normal unsupervised user. It records its state today in JSON files, which we can look at. Don't touch them, but we can look at them. There's a Cascade D, there's a Cascade daemon, which runs continuously, and there's a Cascade command line interface, program, which is what we will use to interact with the daemon. So we will tell it, for example, to add a zone or create a new policy and things like that. Cascade is basically a hidden signer, By hidden signer, we mean that it is a signer program which will really be hidden from the internet. It is not, I repeat, not a program that you will have publicly on the internet. It is not a full DNS server, as I will be able to demonstrate later on. It is really simply a signer, and not, I said simply, very complicated, but simply a signer, and the signer will provide then a signed zone, which can then be transferred to any flavor of open or closed source software that you might have. You might want to use PowerDNS as a secondary, or Bind, or Not DNS, or NSD, basically anything, okay? So it is not a full authoritative server, nor has it been designed as one. Installing Cascade we can do via packages, which NLnet Lab provide. We can also install via Cargo, which is, I think, the Rust package manager. Relatively simple to do. I mean, once I learned how to copy-paste, it was relatively simple to do. Cargo installs so-called crates, and here again, Stefan and I were joking about the amount of crates that we need. Don't worry, Cascade doesn't have 20 million crates. It has something like 250 or 200 or 176, or some relatively low number on my Mac in a virtual machine. Cascade is compiled in, I don't know, 3-4 minutes or something. Yeah, so nothing great. Or nothing tragic. So we have the Cascade configuration. Cascade has a configuration. What is very, very nice is that the command line program, Cascade, the CLI, can actually emit this configuration, which we can then tweak or alter if we so want, which the daemon then will use. In this configuration, we can configure logging, we can configure specific paths to files and directories, we can configure ports and things like that. So basically, you can also run Cascade without even looking at the central configuration, okay? One small warning from me, and that is if you install Cascade via package, currently for the systems that NLnet Labs provides packages for, which at the moment is, if I recall correctly, is only Debian on x86. Be warned, please, that the Cascade is launched via systemd unit file, which very, very strictly reduces the number of directories that Cascade that the daemon can write to. Yeah, so particularly in terms of logging, that can be very important. Cascade brings its own key manager. Theoretically, at one stage in time, these key managers could be replaced. At the moment, I personally wouldn't see a reason to do so, but there is a key manager called DNSSEC, which is compiled together with Cascade. It will drop keys, it will create keys on the file system. These are bind 9 compatible key files. I'll show you one in a moment. I'll have to kill you then, because if I show you my private key, I have to kill you, but it's okay, you'll at least see a key. And the key manager, for instance, is also in charge of key rollovers, which Cascade will then do for us, obviously automatically. Cascade, though, also supports access to a hardware security module. This is done not natively, but via a bridge called, let's change its name, at the bottom, Cascade SHM bridge. It used to have a nice name called KMIP to something or other, KMIP to HSM, I think, but they changed the name. And this then supports, theoretically, any PKCS11 compatible HSM. If you know a little bit about PKCS11, you will know that that can be a huge PITA to get running, but these have actually been tested, and I think 2 or 3 of these I've actually had myself. So really works very well, very well. Now, I would like to propose that we have a look at an actual live demo. We'll do a signing, and I will now move to a command line. I think you see that now. Sorry, this is the moment now where typing becomes very embarrassing because it looks as though I'm an idiot. Oh, sorry, I forgot to start something, and that is I have to relax my hands, sorry. I have to launch a bind name server that we have in the background. System I'm normally quite good at typing, but not now. I need 5 minutes. Sudo system control start named D. Okay, then I will now do following. Cascade is installed, it is running in the background, and I will now do the following. The first thing we need is we're going to create a policy, and I said that the Cascade CLI can emit to standard output appropriate policy information. So I will now use the Cascade utility, the Cascade CLI utility, and here I say Cascade template, please. Template out the policy. By the way, if I don't know how to continue this command, just hit enter and then I get exact instructions what other subcommands are there. This is also quite practical, particularly at the beginning when learning, okay? So I will now do a Cascade template policy and I will write that out into the directory policies and call it NLUUG.toml. Right, and I will look at that policy. And we'll see here there's a lot of information, a lot of comments, etc. I'll just scroll through here briefly. I'm not going to mention everything, but we're going to talk about loader. We see that the policy is required. We can tweak the key manager, for instance. We can say how long should keys be valid for, etc., etc. Which algorithms to use that we're going to change in a moment. We can specify the DS algorithm. Then I can say which TTLs I want on keys. And Cascade will, of course, use this information in the policy to then keep our zone up to date, signed, and running, okay? What I particularly want to do now here is I want to say here use CSK. By default, it's false. I want this to be true. And at the bottom, I'm going to go to the bottom, and I'm going to say send notify to 127. That's my bind name server that's running on the same machine. 127.0.0.1 on port 53. Please check that I don't make any mistakes. Right, that's it. So I've now modified the policy file, and at any point in time, I can do that, paying attention to which zones currently are being signed by that policy. So we have to be a little bit careful. What I will then do is a Cascade, this is so embarrassing, policy reload, and this now reloads any policy. The very nice thing at this point is, for instance, if I have a syntax error in the policy, something's wrong with the policy, Cascade will not load the policy, but will keep the current policy, which is in core, keep that running, keep that loaded. So that is very nice. We only have one policy. Just to verify, in the policies directory, I really only have that one file, so there is only one policy to load, okay? Yes, the Cascade daemon is running in the background as a normal user. So here, as a user JPM. Yeah, it's already running in the background. I can show you that. Can try and show you that. Cascade, and there we go. Yeah, it's in the cargo bin directory. It's running directly from there. I didn't even install it. It just created the binary here and then is running from there. Good, but thank you for asking. Thank you for double checking. My headphones are going away. Something happened to the audio, please tell me. Okay, so we have now reloaded the policy. I have here a small, tiny example.net zone file, which just contains a few records, nothing very special. And we're now going to add that zone to Cascade. So in order to do that, I say Cascade, Cascade zone, add, and give it a source. The source is now from this file .out/example.net. I could also specify as a source the IP address and port number of an authoritative server, which is willing to give me a zone transfer for that zone, but I have it here on the file, so I'm going to load it from there. I will now specify with /policy that we want to use the NLUUG policy and that I am actually installing a zone called example.net, I think I called it. Exactly. So there we go. The zone is scheduled for loading. What we should now see in the keys directory is already key files that have been produced. If you've already once done DNSSEC, you know that these key files, you will also probably know what the key files look like. As I say, this is the moment where this is something that you don't do live, because if somebody now takes a photo, they would in a moment see my private key. So this is the public key of the zone that we just created. this public key, that is the DNS key resource record, which will later on be visible. That is there. No, you can't see that. That will later on be visible there. That will later on be visible in the zone itself. And if we look at the private key, this is the bind-compatible private key. The only thing we have here is a very small key. It's an ECDSA key, so algorithm 13. We just have the base 64 encoded 32 bytes, 256 bits. Okay, so that's basically it. What I can now do is, for instance, I can query our local Cascade. I'm going to ask it, please add port, it's listening at port 4542. I know that because that's the default port that comes along, but we can of course change that if necessary. What do I want? I want to query for example.net, and I want the SOA record, for example, with plus multi. So I can query our local running Cascade for the SOA record. I can also, of course, query the zone, for instance, for an AXFR. But that is all. I can't now query for an A record or for the DNS key resource record set. Once again, Cascade is not a full authoritative server, okay? But it will produce a zone transfer. And you see here that the zone transfer comes out with the RRSIG records, the NSEC records. All this information has been added by Cascade as a signer, okay? So what we also did was, in the policy, we said, please notify the server on 127.0.0.1:53. And what that actually is a bind name server, and this bind name server, if I can find the configuration, is is just listening on, once again, on localhost, there. And here in the center, let's look at the top there, is a zone stanza where I'm configuring example.net as a secondary zone, and I say the primaries is 127.0.0.1 with port 4542. That is our Cascade daemon that is running there, okay? And so in theory, the bind should have already received a notify. Let's look at the logs. Var log name d slash transfer log, I think it's called. And there we should see the following, that we got a notify. We can't see it there, but we got a notify, from 127.0.0.1, and then the transfer was actually performed. Okay, so the transfer came in. In other words, in our bind cache directory, that is in /var/cache/bind, we see there an example.net. And if we look at that example.net, then we see the zone that is being transferred in. Okay, and this zone is really an exact copy of what we got from Cascade, right? Good. So, end of that demo. Just as a matter of course, there's also, for example, Cascade zone status for example.net. I can look at the status of the zone. I would have showed you this earlier, but I noticed a few days ago that there's still a little bug there that hangs for a few seconds. And here we see this is changing. As you see, there's still a to-do here. Yeah? This is changing. But we see the zone. We see this is very clever and very important, which policy was used, the source of the zone. Here I see that I sourced it out of a file, not from a zone transfer, but out of a file. We see review hooks, we'll talk about in a moment, and we see, very important, where the zone can be picked up. It's published and available at that address. So that is that. This is what we did. We did a Cascade template policy, and then we reloaded all the policies, and then we did a Cascade zone add to actually add the zone. Okay. Then we saw a status for example.org. Once again, this is changing a little bit. You see here 2 review hooks, which I configured. These review hooks I'll discuss in a moment. These hooks, these programs, these shell scripts are launched under particular situations. So then we can query, of course, our zone. That's what we did. I'm pointing out very specifically here the serial number. For the serial number, there are 4 different formats. This is a date counter, I think it's called. I personally prefer Unix time. which just adds an epoch timestamp, and I don't have to think about it. Otherwise, I like sorry, I've forgotten what it's called. Something counter, which just increments the serial number by 1. And so this I can configure also in the policy. Yeah? We can have one policy with a date stamp and the other policy with an epoch timestamp, etc. This is something that we configure as and however we wish. And the signed zone is currently in Cascade made available only, it sounds a limitation, it isn't really, as I'll explain in a moment, but only via a zone transfer. OpenDNSSEC, which once again is very soon no more, used to dump out files. Cascade does not yet do that. I think there's an issue of mine which suggests doing that. Meanwhile, I thought of a solution which doesn't need to be implemented in core. But what are we doing here? He's too stupid to realize that the screen is there. What are we doing here? I'm performing a zone transfer from the Cascade server and piping through the DNSSEC verify utility. That's one of the bind utilities to verify that the zone is actually correctly signed. And there we see it actually was correctly signed. This, by the way, is not our zone. How do I know? How do I know that this is not the zone that we just demoed? I know because here we have one KSK and one ZSK, whereas in our example, we just had a combined signing key, okay? Right. I'm just testing you, right? Very good, very good. I was wondering whether somebody would know this. Yes, exactly. Okay, so basically what we do in Cascade is we define a key and signing policy. This is a terminology that Bind today uses, or OpenDNSSEC used to use. Zones take most of the settings out of a policy file. These policies allow for reuse, so we can just reuse them. And in these policies, we create, whatever we wish. And I thought I'd add a little bit of color. And then somebody said to me yesterday, these are the I hadn't noticed. These are the letters of the German number plates superimposed on a Dutch pseudo plate. Okay. But anyway. This is my favorite algorithm, that's why I wrote it there. It's algorithm 13, ECDSA. Okay, policy settings. There are dozens of policy settings. We scroll through that file a little bit. The file is very well commented. I removed all the comments here. Careful, please, I truncated this so it wouldn't be very, very long. All this is not just for CSK, but also exists for KSK and ZSK. We can define whether keys should be removed automatically, the timing information on keys. We can specify whether we want CDS created. Here's my useCSK parameter. Here's the serial policy, yeah? Date counter or Unix time, etc. I think it's called Unix counter, can't remember, Unix time, something like that. But it's documented in the file. And here at the bottom, we had configured the send notify to our authoritative servers, okay? This image or this diagram I stolen from the Cascade documentation. It basically shows the signing pipeline. So a zone comes in on the left here, either via a zone file or via a zone transfer, currently only AXFR. We can have the zone validated. So Cascade for us we can configure in Cascade a program which validates whether what has arrived is actually valid and should be signed. And if the program exits with a code unequal 0, then Cascade will stop. Yeah, and it will tell us, inform us that we need to interact. Then the actual signing occurs via keys that the key manager has produced. We can, in a post-validation step, we can verify and validate that the signed output is correct before it's actually transferred to the authoritative secondaries. In case anybody from DNSSEC is now listening, this would be the point. That's not, once again, sorry, it's really not fair. I know there are very many, very intelligent, much more than I, people at DNSSEC, and they do massive amount of work, and I'm sure they have things like that. I have not yet read a postmortem of what actually happened. Yeah? So this is really just in bad taste. But that is exactly what we can do. Yeah? Make sure that what has been signed is actually valid before we give it out to secondaries, which will pass that out into the world. Okay, and then it goes out to distribution. That is that point where we send it to our secondaries, yeah, to our authoritative secondaries. So we can add our own trusted validation. We can create scripts which are read or used either on an unsigned zone, which is just being read by Cascade, or after the Cascade has actually signed the zone, we'll be able to verify the actual zone. And the nice thing, for me, this is very, very nice. The nice thing is we can use really custom scripts, custom programs to actually do this. Yeah, this is highly important in my opinion anyway. So a custom program which does zone validation, and number one, after loading, but before signing, or number two, after signing, but before publishing. Yeah? And what does this program do? This program can do whatever we want it to do. If it exits with zero, the step is considered okay. If it exits with a value unequal 0, then the step is considered as failed, and the zone can then be rejected or retried at our discretion. But in any case, the zone is halted. So Cascade will then stop, and we have to figure out that that is happening probably via some logging mechanism that alerts us. That is not quite clear how we will be doing that. This is defined in the policy. So in the policy file, there's a loader review or a signer review where I specify a command hook, and here I can also add parameters. Careful, please. Here, in this very small example, I have parameter, unsigned or signed. And this script, this program, can do as much logging, as much talking to us as we wish. So, for instance, here we see reviewing unsigned example.org, serial 12, or reviewing signed example.org, serial 2026, whatever. Yeah, so this was the incoming, this was the outgoing. And let's see what created this log. That is this trivial shell script, which does nothing else than create a temporary file. It will then emit a syslog output. These variables are automatically passed to us. What I then do here is I query Cascade server IP with Cascade server port for Cascade zone. I perform a zone transfer. The result of this zone transfer, I can do once again whatever I want with it. Store it in a file, give it to one of the validation programs. I've here now just commented this out, no? But I can use validNS, for example, on an unsigned zone, or LDNS read zone for, LDNS verify zone, or DNSSEC verify zone, LDNS toolkit, the bind toolkit, to actually verify the content. I could do all sorts of other checks, whether the sufficient keys are in there, et cetera, et cetera, et cetera. And this exit defines on whether, or decides whether Cascade will accept that stage of the pipeline or reject it, okay? Warning, please, and beware once again, if you're running on the system D and you have read-write paths or protect system, then you can't just output a file wherever you want. Yeah? So that, once again, this can be a problem. So rejected zones are actually shown us in the status. So if I look at the status, then I will see here, for instance, that our zone with serial 12, this is on the incoming, the zone was rejected. And possible actions, I can now, at this point in time, I can override or I can reset. Override means go on anyway, yeah, carry on with the next step of the pipeline, even though I know that is wrong. And reset would mean Cascade throws this away and will then, for instance, perform a new zone transfer to actually then go to the, get the source again. So we talked about DNS notify. Cascade will, or can, if we so want, and I demonstrated that, Cascade is able to notify the secondaries, and the secondary servers are typically then our NSD servers, our not DNS servers, our bind servers, our Power DNS servers, our, what else is open source authoritative? Yadifa, who uses Yadifa? Yeah, I expected that. And I think that's about it. And these servers would then perform a zone transfer and then begin serving the signed zone. Okay, so this is really a very, very nice integration in my opinion. So there are few limitations at the moment. Incremental zone transfer outgoing. So in other words, between the signed zone and the outside is not yet implemented. So it's an AXFR, a full zone transfer. I think for most of us normal humans, that should not be a big problem. This is a relatively strong limitation for people who have very, very large zones. So for example, CCTLDs, you think about .de, I happen to know, has something on the order of 17 to 18 million names, or .com has in the order of 160 something million names. Those are really huge. If you have to transfer that, it takes ages. Yeah? But for most normal size zones, whatever normal is, that shouldn't be a limitation. T6 support is not yet implemented, though I didn't look at it carefully, but I saw a few pull requests yesterday, I think it was, and the day before. It's being worked on at the moment, so that is something that is coming. T6 transaction signatures, which permit a secondary server to authorize itself against Cascade, for instance, to say, yeah, you know me, I'm allowed to transfer that zone. CAA record support is currently missing, at least at last tech. Currently also missing is support for shared keys. This is one thing that I have never wanted, but there are people who want it. Shared keys means that we can have a key pair, for instance, and willem.nl and jpmens.net share this key, which causes all sorts of other headaches, so that's why I've never wanted it. But anyway, the people who want them. And there's a limitation of sorts, as I say, of sorts. Currently, HSM supports, the HSM support via the Cascade HSM bridge supports algorithms 8, RSA SHA-256, or 13, ECDSA 13 only, okay? As I say, for me, not a problem, but maybe for you. Good. Other than that, NLnet Labs, I think it's correctly spelled, because I tend to spell it correctly. I hear from Alex it's very difficult to spell NLnet Labs correctly. I've never understood why. Cascade documentation, very good. They are working at it very intensively. Once again, theoretically, within the next few months, there should be the first release. Go ahead, look at it. It's, if you do DNSSEC, really a very, very interesting solution, and most particularly because it can run, as a normal user on loopback address. It doesn't have to face the internet, so basically you can't do really very much wrong. By the way, I forgot to mention, if you do want to migrate, the Cascade client utility or the key manager, one of the two programs, can actually import existing keys. So if you want to migrate from existing keys without performing a key rollover, that should also be possible. Okay, right, that's it.
Thank you. We have 3 minutes for questions.
Speak loud and clearly. I can't hear you.
Thank you very much for this talk. A very interesting topic, and I'd like to congratulate the NLnet Labs people and you and all the others involved for making this possible. I think it's a really step forward.
I'm not involved. I just bitch. That's all I do. Yeah, it's the NLnet Labs people who do the work.
That's also work. I was wondering what the limitations that you were shown. Are any of these expected to be resolved before the release?
Oh yes, I believe so. So for instance, I mentioned already the T6 support is being working on. I'm not sure about these things at the bottom. IXFR support is currently, I think, being worked on. So I would expect most of these things to be solved by the time of release. But I do not know. Yeah. But as I say, my expectation is that that will happen. There's a question in the back there.
Thank you. So I saw in the config file that it can automatically rotate keys. Is there any method or way of working that you know that you can use your existing keys to validate and send an update without going through all of the proprietary APIs that all of the hosting companies use to update your keys? So say I have my zone.
You are now leaving Cascade, no?
No. Yeah. So Cascade automatically rotates the CSK, KSK, and the ZSKs, right?
Yes.
So the ZSKs are signed by the KSK that you publish in the upper layer. So say the .nl or .de or whatever.
No, excuse me. The key signing key signs the resource record set of DNS keys in your zone.
Oh, right. Sorry.
So when you rotate, when you roll the ZSK, there is no interaction with the parent zone. Only when you roll the KSK or the CSK is there then an interaction, because the DS record has to go up.
Right. Sorry.
But that doesn't.
Yeah,
address
yeah,
your
but
question.
yeah, okay, yeah, but so if I saw it correctly, then Cascade can also automatically rotate the KSK after a while. I thought that was
Yes,
a year or
absolutely.
something.
Absolutely. You decide on this time frame. So, for instance, if you think, I don't know why you would, but if you think that key rotation or key rollover is a good thing, then I'm just kidding. I'm not a huge friend of key rollovers. For instance, when was the last time you rolled your house key? When was the last time you rolled your SSH key? Yeah? When was the last time you rolled your SSH host key, unless you rebuilt that host? Okay, but that's not.
We're on the same
so
page.
you decide on how frequently you want to roll. You configure that in your policy, and Cascade will perform these rollovers. Now, if you are, and this is I think the important question that you're asking, if we are rolling or rolling the KSK or the CSK, then as soon as that rollover is in progress, it must be, the DS record must be communicated to the parent zone. For this, at the moment, there is no electric solution. Yeah? Okay. The NLnet DNS server can do that, but Cascade cannot do that. And NLnet DNS can also only do it if the parent belongs to you. So that is something that we would then do manually. We would check via Cascade zone status. Oh, look, the rollover is in progress, has been completed. Here's the DS record. Please go to your parent zone and paste in that DS record there.
Right. Okay.
But I'm not quite sure if I've answered your question.
Yeah.
Okay.
This was yes. This was what I was looking for. Thank you.
Good. Yes, here in front, Willem.
One of the slides showed the folder with the keys, and I noticed that others have read access to your private key.
I'm sorry. Could you repeat that, please?
You showed a slide with permissions. No, not exactly. It wasn't about the permissions. It was about the keys that were generated, but the permissions on the keys have read only for others.
Yes, that is
including the private keys.
That is currently the case.
Okay, because
I would like to answer your question with a question. How many people, if you do DNSSEC-signing and if you have a signer, how many users are going to be permitted to access your server?
Not many, I hope. But
okay,
it's
does
using
that answer
sensible
your question?
defaults.
I beg your pardon?
It's using sensible defaults, which means
in my
that
opinion,
folder should not be
in
readable.
my opinion, they are still very sensible defaults, because on the signer, if you and I are admins of that signer, you and I have access, and if we want to read it, we'll be able to read it.
Yeah.
But admittedly, point taken.
Technically,
I expect that by latest tomorrow morning, you will have raised an issue on GitHub.
I'll take this one now. Okay.
Point taken. Yeah, no question.
Thank you. Okay. There we go. So that's
Is that
it.
my?
Yeah, it's your timer.
Thank you. And I think it's lunchtime now, which is probably the reason you're all sitting here anyway, so you might as well now go away. Thank you very much.